learn the details of implementation, it is still not quite there, because it is too abstract. All discussion is very abstract. We want to see some concrete example. So in this section, we will see a concrete example. Go through all the details using one particular example. Then we can see all the steps clearly. All right. So let's use this array as an example. So let's run one partition from beginning to end, one partitioning from beginning to end, following our standard step. All right. First, we pick the last element as the pivot. So then, let's do our work below. So organize our data, our steps below. All right? Yeah. When we start, we initialize S region as an empty array, L region as another empty array, and U region, all the elements except the pivot in white color. Okay. We use different colors to represent different status for the elements. All right. For the first element, so we do one scan from beginning to end. Okay. For the first element, we see, let's do our first comparison. Compare 2 with the pivot 4. 2 less than 4, so we put it in S region. Okay. Second element A, we compare it with 4. It is greater than 4, so we should put it in L region. Okay, so that's simple. Next element 7, it is greater than 4, so we put it in L region. Very simple, right? Next one, 1, compare it with 4, it is less than 4, so we should put it in S region. All right? But here you can see the location of this one, it is separated from another element in S region. So we don't want that to happen. We want all the elements in S region take consecutive locations. So here, it's not good. Okay? So we want to change it. So how do we change it? We want to make 1 and 2 adjacent. How do we make 1 adjacent to 2 without doing too much work? We don't want to do too much work. We want to do the minimum amount of work to make 1 adjacent to 2. Okay? Yeah. How to do it? Swap 8 and 1. Swap element 8 and element 1. One swap, then we can make S region, L region, all the elements in these two regions take consecutive locations. All right. But here, when we do this, we need an extra space. Here, our extra space 1, we use it for the swap operation. All right. Next. So after the swap, so we have the case here, the next element 3, we'll compare it with 4. It is less than 4, we should put it in S region, and we need another swap. Swap 7 and 3. After that operation, we have S region, L region. See? Yeah. Okay? So we maintain these two regions. Okay? The last element, 5, greater than 4, so it is in L region, so we don't need to do swap. Okay? Yeah. So here you can see, after that, we get the whole S region, the whole L region, and the U region is gone. Okay? All the elements are processed. Okay? Now, the last step, we need to put the pivot element in place. So how do we put the pivot element in place? With the experience we had before, now it's easy, another swap, right? So this time we swap 8 and 4, we can put the pivot element in place. After that, you can see S region, pivot, L region. That is a perfect partition. A perfect partition. So we can do it like this. Okay? Yeah. All right. But if we recall the implementation step, there is still some fine details we need to really pay some attention to. So here, question, how to control S region and L region? In our program, how do we manage S region and L region? Yeah. Here the idea is very simple. We just use two indices, two index variables. Okay? Yeah. For S region, because we plan to use consecutive A locations from 0 through I, index I, and L region we use the consecutive locations in A array from index I plus 1 through J. Yeah. And so here we assume before our final pivot swap step. Okay? The pivot still at the end. Okay? Yeah. Before that. You can see when we grow S region, grow L region, basically we just need to change the value I and J. Okay? Yeah. So when we grow S region, we need to modify I and or sometimes, if necessary, J. When we grow L region, then we need to modify J and, also look at if we need to modify I or not. Okay? But that kind of details we can fix easily in our program. Yeah. All right. And when you swap two elements, that's also an easy step in our program. Okay? So after that, you can see the extra space we need. Extra space number 2, we use it for index I. Okay? For index J, we need another extra space. Here you can see 1, 2, 3. The extra space we need for one partition step, 1, 2, 3. Okay? So the overall, the total extra space, bigger of 1. Satisfy our requirement, our goal, so we do not use too much extra space here. Okay. All right, so that is the details we can see clearly in a concrete example. All right, so we finish B.4. What's wrong?